Hello everyone, this is Rachel Garcia and today we'll be discussing overview of infection process. Infection is the successful invasion of the microorganisms into our body's system. The next topic that I will be discussing is the chain of infection. Chain of infection can be summarized as using the word or mnemonic share me. Share me starts with SH, susceptible host, and then we have A, agent, your infectious agent, R for your reservoir, and E for your entry portal, and then me for mode of transmission, and E for exit portal. So you can easily recall the chain of infection because chain infection is something that you easily share or you share me. Now to start off with the first element in the chain of infection, we have the infectious agent. Infectious agent is the term that is generally used to describe and encompass any material that can cause infection and can lead to a particular disease. There are many forms of causative agent or infectious agent. We have the viruses. Basically, viruses cannot replicate independently in the host cell and stimulate it to participate in the formation of additional similar microorganisms. They are the smallest microorganisms, and a very good example of that is your coronavirus or your SARS-CoV-2. Then we also have the common flu or influenza, the shingles, and the hepatitis. Now, another one is bacteria. Bacteria are the simple one-celled microbe with double cell membrane that protect them from harm. They produce rapidly and considered as the most common cause of fatal infections in human. An example of that is your leptospirosis. Next is the fungi. Fungi are found almost everywhere on Earth. They live in soil, water, or animals, and even plants. They also live inside or outside our body. An example of that is your candidiasis and aspergillosis. And then we have parasitic protozoan diseases. They are much larger than bacteria, the simplest single-celled organisms of animal kingdom. They absorb nutrients from the body of the host, such as malaria and Giardia and toxoplasmosis. How well any pathogen is able to thrive in human hosts depends on three factors. First, we have the pathogenicity. Pathogenicity refers to the ability of the microorganisms to produce particular disease. As you may see, you can find a lot of microorganisms in your skin, but you are not developing disease because they are not harmful or they do not have this pathogenicity. Next is the degree of virulence. Degree of virulence refers to its severity or harmfulness. So at times you may wonder why you did not develop a particular disease where in fact you get exposed to a positive or uninfected person. So this can be deduced from the idea that the microorganisms that you get exposed with has weaker virulence and you have a stronger immune system. Next is invasiveness. Its tendency to invasiveness refers to its tendency to spread, okay, or to get into our system. The next element in the chain of infection is reservoir. Reservoir of an infectious agent is the habitat in which the agent normally lives, grows, and multiplies. Reservoir include humans, animals, and environment. The reservoir may or may not be the source of the infectious agent, or is responsible for the transfer to a particular host. For example, the reservoir of Clostridium botulinum is the soil. But the source of most botulism infection is improperly canned food containing Clostridium botulinum spores. Next is human reservoir. Many common infectious diseases have human reservoir. Diseases that are transmitted from person to person without intermediary host. These include sexually transmitted diseases, and then we have also measles, mumps, streptococcal infection, and other respiratory pathogens, because humans were the only reservoir of these particular microorganisms. An example also is smallpox virus, which naturally occurring smallpox was eradicated after the last human case was identified and isolated. And then we have the different types of carrier. First is the asymptomatic or the passive or healthy carriers. They are those people who have never experienced any signs and symptoms despite being infected. So I believe you are familiar with the asymptomatic type of COVID cases. They are tagged as positive or infected individual. Okay? However, they do not manifest the signs and symptoms of the COVID disease. And next is the incubatory carrier. The incubatory carriers are those who can transmit the disease during the incubation period or before the clinical illness begins. So at times you get to recall that you do not get any exposure with an infected person, but you develop the disease. So this usually happens in particular cases of chickenpox that you could hardly recall getting exposed with it. But you did not realize that you get exposed with the person who had the disease during the incubatory phase. So chickenpox is one good example of incubatory carriers and convalescent carrier, as you may hear from others that chickenpox can be transmitted when they are already in the healing phase. Convalescent carriers are those who have recovered from the illness but remain capable of transmitting the disease. So I have mentioned about chickenpox earlier. Another one is chronic carriers are those who continue to harbor a pathogenic microorganisms such as hepatitis B, Salmonella typhi, the causative agent of typhoid fever, which you can actually have for months or even years after the initial infection, and you get to infect other people as well, even if you do not have the signs and symptoms or you have recovered from that. And even if you have recovered from that for a very long time ago. Another one is frank or symptomatic person. So they are the person who actually manifests the signs and symptoms, and obviously they are able to transmit the disease. Next is animal reservoir. Animal reservoir are also subject to diseases that have animal reservoir. And the same thing goes with human. Human are also subjected to diseases that have animal reservoir. Many of these diseases are transmitted from animal to animal or human as incidental host. The term zoonosis refers to an infectious disease that is transmissible under natural conditions from vertebrate animals to human. Long recognized zoonotic diseases include brucellosis, which comes from cows and pigs, anthrax from sheep. In the local, we also have carabao as sources of anthrax. We have plague for the rodents, trichinosis or trichinosis from swine. We have tularemia from rabbits, and rabies from bats, cats, and dogs. Now, zoonosis newly emergent in North America include West Nile encephalitis, which is believed to be coming from the birds. Many new recognized infectious diseases in human include HIV/AIDS, Ebola infection, and SARS are thought to be emerging from animal hosts, although these hosts have not yet been clearly identified. Another reservoir is your environmental reservoir. Environmental reservoir includes plants, soil, and water in the environment, uh, which may harbor pathogenic microorganisms. Many fungal agents, such as those that can cause histoplasmosis, live and multiply in the soil. Outbreaks of Legionnaires' disease are often traced to water supplies in cooling towers and evaporative condensers. Reservoir for causative agents of Legionella pneumophila. And then another reservoir is the non-living reservoir, which includes soil and water in the environment. They may naturally harbor organisms because it grow in that particular environment. The next element in the chain of infection is the portal of entry and exit. Now, the portal of entry and exit are almost the same or the same site. Let's say, for instance, you have your mouth as your entry when you eat, your mouth as your exit when you vomit or when you cough out blood. Another is your nose as your portal of entry when you inhale, and portal of exit when you exhale or sneeze. The same thing goes with your eyes. It can be a portal of entry, okay, for microorganisms when air is projected to your eyes or when a droplet is projected to your eyes. And it can be a portal of exit when discharges goes out of your eyes. Same thing goes with your ears, okay, and your genitalia and your anus, and your skin as well. Your skin may actually be portal of entry, like your skin has pores wherein the some microorganisms can screw inside your skin pores. And this can also be a way of exit when you develop a particular infection and your skin will be releasing certain discharges. Okay, like what happened in cases of pressure ulcer. So basically, portal of entry and portal of exit are similar. Now, another one is your another element is your mode of transmission. Mode of transmission of an infectious agent is may come from its natural reservoir to a susceptible host in different ways. There are different classifications of mode of transmission. One is the direct transmission, wherein an infectious agent is transferred from one reservoir to a susceptible host by direct contact or droplet spread. So direct contact, um, which is basically a manifestation of skin-to-skin contact. So when you get direct contact or kissing, sexual intercourse, so direct contact can also be coming from direct contact with soil, vegetation harboring microorganisms. So thus, infectious mononucleosis, for example, or kissing disease, and gonorrhea are spread from person to person by direct contact. Another one is hookworm being spread by direct contact with a contaminated soil. And then under direct contact, we have the droplet spread, which refers to spray with relatively large short-range aerosol produced by sneezing, coughing, or even talking. Droplet spread is classified as direct because transmission is directly spread, okay, over a few feet before droplets falls into the ground. Example of that is pertussis and meningococcal infection, which is transmitted from infectious agent to a susceptible host by droplet. Next is the indirect transmission. We say indirect transmission because transfer of infectious agent from a reservoir to a host is passing through suspended air particles, inanimate object or vehicle, or animate intermediary or vectors. Next is airborne transmission, in which infection occurs, okay, through dust, droplet nuclei suspended in the air. Airborne dust includes materials that has settled on surface and become resuspended by the air current, as well as infectious particles blown from the soil by the wind. Droplet nuclei are dried residue of about 5 microns in size. In contrast to droplet, the fall to the ground within a feet, droplet nuclei may remain suspended in the air for a long period of time and may be blown over great distance, an example of which is measles, which has occurred in children who came into physician's office after a child with measles has left long ago, because measles virus remains suspended in the air. And then we have vehicles that may indirectly transmit infectious agent, which includes food, water, biologic products like your blood, fomites, or inanimate objects such as your hankies, beddings, surgical scalpels. A vehicle may possibly carry a pathogen or food or water which may carry hepatitis A virus. Alternatively, the vehicle may provide an environment in which the agent grows, multiplies, or produces toxins, as improperly canned foods provides environment that supports production of botulinum toxins by Clostridium botulinum. Next is the vectors. Vectors, we have mosquitoes, fleas, ticks, which may carry an infectious agent through purely mechanical means or by support growth or changes in the agent. Example of the mechanical transmission are the flies carrying Shigella on their appendages and fleas carrying Yersinia pestis, the causative agent of plague in the gut. In contrast, in biologic transmission, the causative agent of malaria or guinea worms disease undergoes maturation in intermediate host before it can be transmitted to human. Now for the susceptible host. The susceptible host, which is the final link in the chain of infection, may depend on genetic or constitutional factors. Another one is a specific immunity and non-specific factors that affect an individual's ability to resist infection or to limit the pathogenicity of invading microorganisms. An individual's genetic makeup may either increase or decrease susceptibility. For example, person with sickle cell trait seem to be at least partially protected from a particular type of malaria. Specific immunity refers to protective antibodies that are directed against specific agents. Such antibodies may develop in response to infection, vaccine, toxoid, okay, or may require by transplacental transfer from the mother to fetus, or by injection of antitoxin and immune globulin. Non-specific factors that defend against specific infection includes the skin. So there are people who actually have poor skin integrity or born with it. Mucous membrane, gastric acidity, cilia, and respiratory tract, the coughing reflex, and non-specific immune response. Factors that may increase susceptibility to infection by disrupting host include malnutrition, certain vices like alcoholism, drug addiction, and certain diseases or therapy that impairs non-specific immunity. So if you're like receiving steroids therapy, so your immune system get weak. Another factor that may predispose specific hosts is the age. The young and the very old have either weak immune system or immature immune system or degenerated immune system. Certain work uh, may predispose a susceptible host to a particular disease, like the frontliners are more susceptible to acquire COVID-19 because of their constant exposure of direct care to the patient. Another factor that we may be able to consider are those people who undergo surgery wherein the first line of defense is being cut, and that will permit um, invasion of microorganisms. So another is those people with immune diseases, okay, like that of HIV/AIDS, who are immunocompromised, those with cancer and other diseases that may impair the immune system. So there are many factors to consider in the chain of infection. And what is important is we are able to see the link between each chain. And another is that we are able to break the chain of infection. So let's say, for instance, if we want to break infectious agent like bacteria, we can give disinfectants, antimicrobial, we can do sanitation, uh, and then we can take away this infectious agent by using germicidal and then aseptic technique. Another one is we can do away from this by doing your hand washing. And then for the reservoir, we can do certain cleaning, hygiene for your pets and other domestic animal. We can do certain pest control, or we can do a certain infection control policies like sanitation, sterilization, disinfection, and of course hand washing. For the portal of exit, we can have your cough etiquette. The open wound can be covered with gauze. And then for the reservoir, we can clean the dirty surfaces, and then we can clean the other surfaces of the canned food that we are going to eat. And then we have water sterilization, or this water um, distillation. And then we can also do certain soil cleaning, okay? And then for the mode of transmission, we can do hand hygiene, personal protective equipment, we can wear the barriers, and then we can maintain food safety standards, cleaning and disinfection, sterilization, and we can also do isolation or quarantine. Now for the break in the chain of portal of entry, again, we do hand hygiene, personal protective equipment. We can have uh, removal of certain catheters and other tubes with using aseptic technique. And then for the susceptible host, we can actually have boosting immune system, nutritional status, and then having a positive outlook in life, and immunization. We can give a particular vaccine or immunoglobulin. We can do certain patient education so they may know how to break the chain of infection, or how we can prevent a particular disease. And we may also be able to provide certain PPE for those vulnerable groups. And then provision of the health insurance is also important, knowing that when you get the disease, you have to fight it back, and of course you need money or health insurance to help us go through the uh, clinical management process. So if we can break a link at any part of the chain, we can stop infection from rising. That is one good thing about infection or infectious disease. Infectious disease is easily transmissible, or you can transfer the disease, or it can easily be spread. But observing the proper hand washing and other breaking the chain protocol will help us prevent the disease from spreading. So that ends our discussion on overview of infection process. And again, this is Rachel Garcia. See you in my next topic.